Here's our next one. You can write this with a sine or a cosine. You don't have to do both. And the last one. Okay, pass those forward. Okay, going through these. Or probability equates to what operation? Addition, but you always have to remember to subtract the probability of both. Okay, you can't double count. Trig function format. So, by the way, if you want to cheat on your calculator, I'm going to show you how. If you were to ever have some list in there and you could put in whatever list you wanted, a lot of these, a lot of these regressions, if I do stat, calc, a lot of the regressions will give you the format if you forget. For example, if I go down to a sine regression, shoot, I wonder if it's going to, I don't have two lists in there, so I'm just going to put L1 for both of them in case. Shoot, I would have to enter data. Edit, let me just, I'm going to do this and clear this and just enter. I just need to enter any data, who cares? I'm not really running a regression, I'm using my calculator to cheat a little bit. So if you forget the sine regression, list 1, list 2, and calculate, oh, why is it giving me an error? Why is it giving me an error? Maybe your calculator can't be used. What's that? Oh, you're right, it's not. I don't know if it has to be, though. Maybe that's it. I want a scatter plot. Usually you don't have to have it on to run a regression. You have to have it on to see a scatter plot, but you don't have to have it on to run a regression. I wonder if it's because of the iterations thing. Invalid dimensions. I thought I was going to cheat and I can't. One.
So you made those numbers up.
I know, and I think that's why I think my numbers aren't good enough, but
It is.
if I actually had good numbers, but I'm a little bit baffled as to why. Come on. No. Oh, it's not going to work. Well, if I run I'll kind of get at what I'm talking about if I had numbers that work. If I ran a linear regression, like at the top, it gives you the basic format for a line, mx plus b, right? If I ran a regression in trig, it's going to give me this with an A, B, C, and D. Now, for just the format flashcards, I don't make you tell me what A, B, C, and D are, but just to review, the absolute value of this number is our amplitude. B helps us calculate the period, because period equals 2 pi over B. C is your phase shift, your horizontal shift, and D is your midline. But we don't need that for that card. The continuous exponential change formula, that's your what? It's got a nice one syllable word, PERT, your PERT formula. If something's continuously changing exponentially, it's PERT. The other one is our basic exponential change formula that we just kind of went over on that first question on your quiz today. And the other one is compound interest that you have to know, but PERT is probably the easiest one. The word continuous should be your giveaway there. The remainder theorem. So you have to know that when you calculate f of b, that is the same as your remainder when your function is divided by the factor x minus b. Okay? Anytime you plug in the root, it's going to give you what the remainder would be if you were to do long division by the factor. And an odd degree function. This is not an odd function. Odd functions are regarding symmetry. This is an odd degree function. One thing that dawned on me yesterday is to kind of clarify more between odd degree and odd function, is that any function can be odd. Okay? Doesn't matter the type. It could be a linear one that's odd, it could be a quadratic one that's odd, but in order to be an odd degree or an even degree type of function, we are exclusively talking about polynomial functions. We are talking about things that are ax to the 8th power plus bx to the 7th plus cx to the 6th. We're talking about long-winded polynomial functions. Okay, and the degree part is all about their end behavior. Odd degrees have opposite end behavior on either end. So if they're negative odd degrees, they start low, end high, aka negative slope. What I said about the a value, if it's a negative a x to the odd power, then it starts high, ends low with a negative slope. If it's a positive odd, it starts low, ends high with a positive slope. And then on the parabola standard format, again, I could use my calculator to cheat here. I could run a regression that's a quadratic. Parabolas are quadratic, and when you do that, you should at the top of your screen, unless I get another error here, there's your standard format, as opposed to vertex format. Vertex format is this, and that's a different flashcard. There's two main formats for parabolas that we have to know, okay? And this one is standard, and this one is vertex, okay? So those are the flashcards for the day. Any questions? Okay, additional questions on last night's homework. Riley? 33. We were on test 4, right? We were? Test 5 already? Look at us. We're cruising. 33. Did you enter your data? Okay, can I see your calculator so I don't have to redo it?
I cleared that.
Why did you clear it?
I don't know which value to clear it. I can read through the
Molly, let me see yours. Did we already have this discussion? What reason would you guys have to go back and clear it unless there was another set of data to type in? Again, leads me to believe we're not actually doing the problem. Who's got it typed in? Thank you, Cole. Okay, so our data's already typed in, and the x-axis was obviously the number of years since, does it say? Okay, so x equals 1 for the year 2005, so that's exactly what Cole did. Excellent. So first of all, part A, average rate of change. That's going to be your slope formula between 2005, 1.78, and 2014, 3.33. And this is before they told us to use 1 for 2005, and that shouldn't be a problem, because when you do y2 minus y1, you're going to get the same number regardless. And when you do 2014 minus 2005, you're going to get 9 regardless of whether you treat that as 1 and 10 or 2005 and 2014. Was that the issue? Was there a certain part, Riley?
There's one question to me.
Okay. average rate of change moving forward cannot be confusing. It is slope. It is guaranteed to be on there, and it should be a cupcake of a question, okay? So maybe I should add a flashcard on that. Average rate of change on the front, slope on the back with the formula. Would that be an easy flashcard, hopefully? I'll maybe add that to the list. So, and this one says, it does say to include units. So if I do the 333 minus $1.78, that's in money. So that Y2 minus Y1 is going to be $1.55 divided by 2014 divided by minus 2005 is going to give us 9, and those are years. And then you just divide out those numbers. So 1.05 divided by 9 gives me a nearest thousandth. So I got 0.11666, so tenths, hundredths, thousandths. That 6 is going to have to be rounded to a 7 because of the 6 that follows it. So $0.117 per year. Write an exponential regression. So here's where we need to enter our data. Cole's got it all entered, excellent, and then it's telling us what regression. So it's not making us figure out what regression we want to run. We don't have to turn our scatter plot on and see what the shape is. They're telling us run an exponential, so we can just go stat, calculate, and go down to exponential, option 0 right there. Hit enter. We've got list 1, list 2 as our x and y coordinates, all is well. There's our equation. And like I said, they give you the format for an exponential right at the top. And then you just fill in, it says round the coefficients to the nearest thousandth. So, this glowing screen is 1.790 tenths, hundredths, thousandths. So 1.790 and 1.068 for our b. So y equals a times b to the x turns into y equals 1.790 times 1.068 to the x power. There it is. Based upon your regression, what is the average rate of change from 2005 to 2014? So not based on our actual data anymore, based on the regression. So now we need to come up with our own points. For year 1, which is 2005, if you plug in 1, what do we get? So if I quit and plug in 1.790 times 1.068 to the first power, I'm going to get a y coordinate of 1.91172. And then year 2014, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be year 10. That's going to be based on my regression equation. I have to plug that in, 1.790 times 1.068 raised to the 10th power, 3.455, and I'll write that down. And then it wants us to calculate the slope there. So this number, y2 minus y1, so the 3 number minus the 1.9 number, and I'm going to type it in exactly, gives me 1.544214939, and that's in dollars again. Over 10 minus 1 is just 9 years still. So the regression equation tells me that the change over the 9 years was 1.54. The data told me it was 1.55, so it should be slightly different. Divide that by 9, and we get 17, round to the nearest thousandth, $0.172 per year. So that's really 17 cents per year-ish, but they did say to round to the nearest thousandth. Use appropriate units. So that's where you have to know that these numbers were your dollar amounts, so that's dollars. These numbers were your years, so that's years, and then the division dollars per year. Why is there a difference between your answers using the table and using the regression equation? Okay? The table are the actual results. The regression equation just gives us the best overall trend. Okay? And we know that when things are a trend, and that's just our best overall analysis of how something is changing, that doesn't mean it's actually changing by that exact amount every year. For example, people say on average the stock market increases by 5% each year. Okay, that might be a good on average, but some years it's 4.9%, some years it's 5.7%, some years it's 2%, some years it's 11%, but they're giving us kind of the best regression, the best overall general trend so that we can predict the future most accurately. There's no way you're going to be able to predict the future if you need every single actual number. Okay? So something along the lines of the table is giving us the actual changes and the regression equation is giving us the best predicted rate of change. Other questions? Kaylee, what was yours?
34.
She said I had a mistake on my answer key, which is very possible. Graph this and label the roots. So, again, if I wanted to do it by hand, I would try to factor this, just like the question we ended off with yesterday. Anthony, can you give that back to Cole, please? But it doesn't say anything has to be done algebraically, so I'm just going to use my calculator. I'm going to turn my plot off, by the way. Make sure that's not highlighted. X to the third plus 4x squared minus 7x minus 10. I'm going to zoom 6 to get it back to standard. And my roots are most important. And they look like they're whole numbers, so I'm going to go with it. -1, -2, -3, -4, -5. So when they say to write this, and obviously I can just copy down the picture. When they say to write it in factored form, if you have a root at -5, what's your factor? X plus 5. If you have a root at -1, what's your factor? X plus 1. And if you have a root at 2, what's your factor? Yeah, x minus 2. And there's just your function in factored form. Normally there's an a value out in front, but the a value was 1, and so this a value is 1. Good? So then, where was my mistake? I'm sure.
You had X plus 2 and X plus 1.
Oh, so I had them flip-flopped. Well, I still have x plus 1.
No, you had X plus 2, X minus 2.
Okay.
And never an X plus 1.
Oh, gotcha. All right, so I just screwed it up. But that's hopefully a pretty straightforward question. Tyler?
5.
Number 5?
Yeah, I just didn't get the correct number.
We didn't have to do 5 last night, did we? Was it 1 through 10? Oh, I lose track because I'm always planning ahead for the next day. All right, so the number of vacation days used by 15 employees. Okay, so if you want to, you could type this into your calculator, type in the data. Did anybody do that? Now that you probably would have cleared out to do the problem later in the assignment, but do you still have it in there?
Actually, back in.
Okay, will you bring it to me? I will, okay, good, thanks Jake. I will say this. We should just know this, even without the calculator. There were 2 percentages I made you memorize, being within 1 standard deviation and being within 2 standard deviations. And the general percentages that we hang on to for what a standard deviation's definition even is that 68% of the time, the data is within 1 standard deviation, and then what's the next percentage bump up to? 95. So was this just 67? Yeah. So you really didn't need to put your data in unless these were so close that you needed to actually see. So here's his data, and I can do stat and calculate my one variable statistics, which is going to give me my standard deviation, and it's 3.4, we'll say. Okay? So 3.4 is the standard deviation, and our mean is 4.1. So it's 4.1 as your average, give or take 1 standard deviation of 3.4. So if you add 3.4 to 4.1, you get 7.5. If you subtract, you get 0.7. So if you look at all of the ones that fall between 0.7 and 7.5, 0.7 and 7.5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 15, and 10 out of 15 is 67%. Okay? Cool?
I feel like unit 5 is, I would say like I looked at the institute as well, so you had 1.3 repeating.
I had what?
You had like 1.3 repeating items for like
Yeah, you're right.
no,
Use 1 point, or
for your
3.34, or 3.38.
Okay, so that's what this is, 3.38. I just rounded one more decimal out on my answer key than I did here.
No, not that, the mean.
The mean was different,
Yeah, it was 1.3.
and not 4.13 repeating?
Yeah.
Oh, so I made a mistake on it? So did I pick the wrong answer?
No, it was.
Oh, okay. So that's a mistake too, thank you. Yeah, no, it's obviously, I must have just missed that 4 when I did it. Anything else? Chance. Number 10. Okay, so we've got a natural log function and a polynomial function. What is the greatest solution? So the solution is are the x values. So I'm going to, I'll cover that up so it's not distracting us. You're just going to use your calculator here. We don't know how to solve this system with a natural log and a polynomial. So you're just going to type in both of those and see where they cross. Did you do that?
No, I didn't know you had to type it in the calculator. I could just type it equal each other.
Which you do, and if you, any system, if they don't say to do it algebraically, God help you, use your calculator. How fast is that, okay? Just know that if they're asking for the solution to when these equal each other, that's just your x-coordinate of your answers. So you type this into one equation, this into the other equation, open your window enough to see, and just do second trace intersect. Is that clear? Good. Okay, anything else? Okay, pass it forward. I think we have time for 1 or 2 questions, 21 through 24. We'll start with 21. And this is obviously on test 5. So, read that quickly. Quartic function means what's the degree? 4. Do we all agree that this is an even degree? Is that an even degree? Yes, because the end behavior is the same. The A value, should it be positive or negative since it's opening up? Positive A opens up or opens down? Opens up. So all of these, though, have a positive A value of 1, so that's not very helpful. Which of the following is the correct factorization? Well, we've got a root at -7, so what factor are we looking for? X plus 7, so it's between 2 and 4. We've got a root at -2, so what factor are we looking for? X plus 2, so we're still between 2 and 4. We've got a root at 0, so what factor are we looking for? X minus 0 or just X, right? Okay, so that's the difference between 2 and 4. 2 is only a cubic, because that's 1 degree, 2 degrees, 3 degrees. 3 roots, triple. So they missed the X and 2, the answer should be 4. And then 22, very quickly, this should be a cupcake. The 5th root of X to the 3rd power. Raise your hand if you think it's 1. The 5th root of X to the 3rd. Raise your hand if you think it's 2. Raise your hand if you think it's 3. Good, excellent. So it was, yep, it's the denominator's outside. Perfect. I doubt you'd ever have something that straightforward, but it's a good skill to remind us of. So tonight, second half of test 5. Any questions? Good. Have a good day.